Inverse variation is a little bit different than direct variation. Inverse variation is a specific relationship in which there is a constant product, okay? So that's your x times your y between all ordered pairs. Okay, and the inverse variation equation is written in the form y equals your constant divided by your x value. Okay, so remember, direct variation is written as y equals kx, like our slope. Inverse variation is y equals k divided by x. So for our constant, we're going to use our product here to figure out what our constant is. So instead of having to divide like we did with direct variation, for inverse variation, we just have to multiply. So it doesn't matter what you multiply, as long as they all equal the same number. So we're going to do 1 times 20. Okay, and 1 times 20 I know is 20. And I can check 2 times 10 is 20, 4 times 5 is also 20. So my constant here is 20. I'm going to go ahead and put that into my equation of y equals k divided by x. So y equals 20 divided by x is my inverse variation equation for these points. The same idea for number 2. We're just multiplying our x and y together for inverse, because the inverse is like the opposite. So the opposite of dividing is multiplying. So we're going to go ahead and do our multiplication. It does not matter what points you pick. I'm just sticking with the first one. Okay, 1 times negative 28 is in fact negative 28. 2 times negative 14 is negative 28. 4 times negative 7 is also negative 28. So in my equation, I'm putting y equals our constant of negative 28 divided by x. And that is our equation for number 2. Number 3, same idea. Now we have a table. So you're just taking your x value times your y value. Okay, so negative 5 times 2.4, negative 3 times 4, negative 2 times 6, negative 1 times 12. I'm going to use negative 3 times 4 just because I don't want to use the 1 with the decimal. Okay, so I'm going to do negative 3 times 4, and that will get me a negative 12. Double check. Those all do, in fact, get negative 12. So my equation is y equals negative 12 divided by x. Number 4, same idea. You can multiply by the decimals if you want. You definitely should to check your answer, but to initially find your answer, you don't have to. I'm going to use these two right here. So I'm going to use my constant equals negative 1 times negative 6. And a negative times a negative is a positive, so I get 6 as my answer. And if I check all of these other ones, I will in fact get 6 as my answer. So my equation is y equals our constant 6 divided by x. Now, graphing is a little bit different. Whereas the direct variation made a straight line, these make kind of a curve, and the points on the ends of them are actually called asymptotes, which means that these lines never actually touch the axes. Okay, so even though you're graphing and gets super, super close, they never actually touch the x or y axis. To figure out what our graph needs to look like, okay, it tells us that our constant of our inverse variation is 16. So that means my constant, remember, is my x times my y. So x times y needs to equal 16. So I'm going to create 2 different tables here. Okay, I'm going to stick 1 with my positives and then 1 with negative values, because you know a negative times a negative is also a positive. So I'm going to go ahead and just list my factors: 1 and 16, 2 and 8, 4 and 4, 8 and 2, and 16 and 1. And then I know since the negative times a negative is a positive, I can just recreate this table, but make them all negative. So what I'm going to do now is I'm going to go ahead and graph my points. So I'm going to go over, these are by 2s. Okay, so over 1, up 16. Over 2, up 8. Over 4, up 4. Over 8, up 2. Over 16, up 1. Now I'm going to try my best to connect these with this tablet. Whoa, okay, not bad. There. So that's just one of the lines. You can see it's kind of arcing, and it never actually is going to touch X or Y. So now I'm going to go ahead and graph the other side. Go over to -1, down to 16, or -16, over -2, down to -8, -4, -4, -8, -2, -16, -1. Now I'm going to try and connect all these ones. Okay. Okay. I'll try my best. Try your best to connect them as well. If it's not perfect, that's okay. So that's what our graph looks like. So all inverse variation graphs have these arcs to them. They're either going to be in this spot, or you'll see them in quadrants 2 and 4. Okay, so if you're getting a positive as your constant, it's going to be in 1 and 3. If your constant is a negative, it'll be in 2 and 4. And you'll see what that looks like on the back. So on the back, we have more examples. I'm going to have you go ahead and graph these on your own, and then you're going to check your answer with what I have. Okay, so if you finished graphing these, you should have graphs that look similar to this. As you can see for this one, it's a positive constant. So again, it's in quadrants 1 and 3. And you have all your factors listed out. Now, obviously, you can't get all of these points on this graph. That's just not possible because it only goes up to 20, and that's okay. Put as many as you can. If you can't fit them all, that's not an issue. Get as many as you can to get that line as exact as possible. Okay, and then obviously the negative ones for the quadrant 3. For the negative one, as you can see, it is in quadrants 2 and 4. And your negatives and match up with a positive, and your positives match up with a negative. So this is what your graph should look like for a positive constant and a negative constant. Okay, so now that we're done with the graph, we're going to go ahead and move on to the last part, finding missing values. This part is very easy. It's actually one less step than what we were doing for direct variation. With direct, remember, we set up the proportion and we solve because our ratios are what tell us our constant. In inverse variation, our products tell us the constant. So we need to just multiply our numbers to solve for our variable. So we're just skipping the step where we set up as fractions, and we're basically at the cross multiplying part in terms of solving. But you're going to multiply these two numbers to multiply these. So I do 12 times 14 equals -24y. Okay, just for this one, I did write this out, but in the future, I may not write those out. So 12 times 14, you get 168. And that's -24y. Okay, and divide both sides by -24. And y ends up being -7. Okay, so it's super easy. You just multiply and divide. So I'm going to multiply these two. 6 times -10 is -60. 3 times y is 3y. Divide both sides by 3, and you get y is equal to -20. For number 9, same idea. Multiply, multiply. So I get 9y equals -18 times 6 is -108, which means y is going to be -12 when I divide both sides by 9. Number 10, multiply, multiply. -7 times x equals 21 times -3 is -63. Divide both sides by -7, and you get a +9. Same idea down here. If y is this and x is that, find x when y is this. So we're doing 9 times our -6 equals x times 3. So 9 times negative 6 is negative 54 equals 3x. Divide both sides by 3. X equals negative 18. Same idea here. 16 times negative 3 equals negative 6 times x. Negative 3 times 16 gets me a negative 48. And then I'm dividing that by negative 6. And x will be a positive 8. Okay, so I'm doing 12 times negative 6. And negative 24 times x. 12 times negative 6 is negative 72. Negative 24x stays the same. Divide both sides by negative 24, and I get a positive 3 as my answer. And the last one, we have a negative 8 times negative 7, and that'll be this equal to 4 is negative times y. Okay, negative 8 times negative 7 is a positive 56 equals negative 4y. Divide both sides by negative 4. Y equals negative 14. All right, so that is all for inverse variation. Tomorrow we're going to be talking about word problems involving direct and inverse variation.